This video will be as a revision for redox reactions. Okay, at first you have to know that redox reactions are two types of reactions: oxidation reactions and reduction reactions. Let's start with oxidation reactions. Oxidation reactions, from the word, you can know that it's the reaction with oxygen. So oxidation is related to oxygen or gaining oxygen. Let's take an example. Magnesium plus O2, magnesium oxide. So since the magnesium reacted with oxygen, with O2 gas, so this is oxidation of magnesium. So this reaction is the oxidation of magnesium. There is another way, more specific way, to know that any equation have oxidation or reduction reactions. Now let's talk about, or let's see the oxidation state. Oxidation state, oxidation number, sometimes we can call it charge, valency. All these are the words of the same thing, oxidation state. Let's talk about the oxidation state of each of these elements and elements inside the compounds in this equation. I will write the equation again. Mg plus O2 MgO. Okay, the oxidation state of any element as it is as an element is 0. So the oxidation state of magnesium here is 0. The oxidation state of oxygen here is 0. The oxidation state of magnesium and oxygen in the compound will not be 0. It will have an oxidation state, a number that shows the oxidation state. Okay, magnesium, since it's in group 2, so it will have an oxidation state of +2. Oxygen, since it's in group 6, so it will have an oxidation state of -2. Now let's compare the oxidation states of each element before the reaction and after the reaction. Mg, it has the oxidation state of 0, and then the oxidation state became +2. From 0 to +2, from 0 to +2, this is an increase in oxidation state. Increase in oxidation state is called oxidation. Oxygen, the oxidation state of oxygen is 0 here and is -2 here. From 0 to -2, this is a decrease in oxidation state. Any decrease in the oxidation state is called reduction. So from 0 to +2 in magnesium, this is oxidation. And from O2, from 0 to -2, this is reduction. So this is a redox reaction, oxidation of magnesium and reduction of oxygen. Okay, now in terms of electron transfer, what happened in this reaction? Magnesium in group 2, having the oxidation state of 0. It has the atomic number of 12, so the number of protons is 12, the number of electrons is 12. How did it become as +2 ion? It lost 2 electrons. Because it lost 2 electrons, the number of protons is now more than the electrons. That's why it's positive. The oxygen, from 0 to -2. So it gained electrons. How many electrons did each oxygen atom gain? 2 electrons. So gaining 2 electrons. So this is for the magnesium, this is for the oxygen. So magnesium lost 2 electrons, so losing electrons is oxidation. Oxygen gained 2 electrons, so gaining electrons is reduction. Now we will write half reactions. Why do we call them half reactions? I will explain this afterwards. Okay, when writing half reactions, let's start with magnesium. Magnesium, as we said, it has the oxidation number of 0, and then it gave me the oxidation number of +2. So this magnesium lost, as we said, lost 2 electrons and gave me Mg +2. Okay, in chemistry we can't write, or we don't write the chemical equation with minus. We can say magnesium minus 2 electrons equals magnesium +2. So instead of writing minus 2 electrons here, we just write them here plus. So magnesium split, let's say, to Mg +2 and 2 electrons. So this is the half oxidation. Okay, let's talk now about the oxygen. It was O2, and then it's O2 negative. O2 to O2 negative. Okay, before working with the electrons, we have O2 here, so 2 atoms of oxygen, and here 1 atom. So we have to just balance the equation to have 2 oxygen atoms here and 2 oxygen atoms here. Okay, this oxygen molecule having the oxidation state of 0, it's gained electrons, as we said before, to become O negative 2. Each atom gained 2 electrons to be oxygen negative 2 ion. In this equation, we have 2 atoms. If each atom gains 2 electrons, then the 2 atoms will gain 4 electrons. And because these 2 atoms gain 4 electrons, we have to write here plus 4 electrons. Okay, now let's write the overall reaction. Okay, first let's see the number of electrons in each half equation. Here we have 2 electrons, here we have 4 electrons, and this is not acceptable. The number of electrons should be the same in each equation or in each half reaction. So this one, we have to multiply it with 2. If we multiply it with 2, then the reaction will be 2Mg 2Mg plus 2 plus 2 electrons. This equation, 4 electrons. 4 electrons plus O2, 2O negative 2. Okay, since the number of electrons is even, we can omit them together, and then we will write the arrow, the reactants in each equation before the arrow together. 2Mg plus O2. And the products after the arrow together, 2Mg plus 2 plus 2O negative 2. This is the overall redox reaction.